Following our discussion at the lecture today about conditional versus unconditional expectations, I want to provide a simple illustration of the difference between the two. Let's consider the stationary Ar1 process, which is given by yt equal to 0.5 multiplied by yt minus 1 plus epsilon t. And assume we have a sample going from t equal 1 to up to 100. We make the assumption that epsilon t is normally distributed with mean 0 and variance 1. So epsilon t follows standard normal distribution. We also assume that it is independent over time. So epsilon t is IID. That implies that the expected value of epsilon t is equal to 0. So the Ar1 process that we have here, we will return to later, and we will explore all the details of such models. But for now, just note the following. The process we have here is a univariate process for yt given its own past. So we can use this to illustrate the difference between the unconditional and the conditional expectation. So the first thing to note is that the expected value of yt is equal to 0. So that is the unconditional expectation of the process is 0. It means that the process here is stationary and it has an unconditional mean of 0. Later we will return to this type of processes and we will show that this actually holds. So in our case here, we have an unconditional mean of 0. Let's assume that we want to make a forecast of y101 conditional on y100. So we are conditioning on y100. So instead of treating this as a random variable, we now fix it at a given value. And let's, for simplicity, just assume that this value is equal to 2. So let's assume that we have a plot of the process like this. And it ends up here. So what we have here is t. This is equal to 100. And here we have observation y100, which is equal to 2. What we have here is 0. So this is the unconditional mean of the process. If we want to make a forecast at point 101, conditional on the observation that y in period 100 was actually equal to 2. How do we do that? Well, to do that, we simply consider the conditional expectation of y101 given that y100 was equal to 2. Normally, when we work with the theory part here, we do not say that it's equal to something. So we just condition on y100, and that implicitly means that we condition on that random variable taking on a specific value. So in order to derive our conditional expectation here, we can simply plug in from the Ar1 process that we have up here. So note that we can write y101. If it follows an Ar1 process, we can write it as 0.5 times y100 plus epsilon 101, like this. So let's use that plug in to our conditional expectation down here. And we get the conditional expectation of 0.5 times y100 plus epsilon 101, conditional on y100 being equal to 2. Now, we can, of course, when we condition on y100 being equal to 2, plug that in here. So that gives us the expected value of 0.5 times 2 plus epsilon 101 conditional on 101 being equal to 2. So the first part here, that's just equal to 1. This is a constant, so the conditional expectation of 1 given y101 is just equal to 1, plus the expected value of epsilon 101, given that y100 was equal to 2. And this term here, our conditional expectation of the shock epsilon t at observation t equal to 101, that is equal to 0. So there's no information in y100 about the expected value of epsilon next period. The conditional expectation is 0. So in the end, what we get here is a conditional expectation which is equal to 1. If we plot it here, this is what we get. So this is our expected value of y101 given that y100 was equal to 2. Note that this is fundamentally different from the unconditional expectation which we had here. The unconditional expectation would be down here. So this is our unconditional expectation of y101, which was equal to 0. And the conditional expectation we just saw is equal to 1. So the difference here is that the conditional expectation takes into account that at observation 100, the process took on a value of 2. It is a predetermined observation. We already see it at that point in time. And when we forecast one period out in the future and we use that, we make a conditional forecast and we get an expected value of 101, of y101, given that y100 took on a value of 2, which is equal to 1. So this illustrates the difference between the conditional and the unconditional expectation. So as I said, later in the course we will return to the class of autoregressive models, AR models, and we will understand all the details behind this. But for now, this is just a simple illustration of the difference. Thanks for watching.